We're good? Okay. All right, so I'll admit one confession when I start off is I'm not sure I even know what DevOps is myself. So I started doing systems management software a really long time ago, and when things really started getting off, it was all about automating IT systems, and things started to take a more cultural bent. And I went to a lot of these kind of events, and I started to hear the same things again and again. Dev teams and ops teams should talk, et cetera, et cetera. And if you're like me, after a while, you go to these events and you're like, I might not have learned anything. So this talk is a little bit about challenging expectations and some of the things that I've felt over my career as a developer over the last like 15 or so years as they relate to things that are popular in the DevOps community today. And I think what we really have is a group of people with a set of common interests that tend to overlap, but not really any one particular subject, and that's okay. So as background information, in early 2012, I created a project called Ansible. Some of you may be using that today. If so, great, thanks. But Ansible was named after a science fiction book I really liked called Ender's Game. And it was all about sort of a kid who learns to be a really good commander and accidentally exterminates an entire race of aliens and feels really bad about it. That's not really relevant to this talk. It's not really why I named Ansible. But sort of relevant to this talk itself, Orson Scott Card wrote a follow-up to Ansible called Speaker for the Dead. I didn't really care for the book. It wasn't nearly as good for me, but it had an interesting concept in it. That concept was that when somebody would die, you would research their life and kind of give this very honest eulogy that you really understood them and what made them tick, their faults, the good things about them in great detail. I'm not dead, and software isn't dead, but a lot of people go around saying that Waterfall software design and monolithic software architectures are dead. And I want to talk about that a little bit because I don't think we've really given them a fair look, and I think there's some lessons to be learned that affect the way that we deploy our infrastructures today. So a few topics: Waterfall versus Agile, monolithic versus microservices, the labels, spin, and assumptions that we apply and what that does to affect our thinking about these things, and an appreciation of the very recent past. So looking at this crowd today, we do have a lot of people that were definitely around in the 90s and early 2000s as I were, but a lot of people in software are pretty new and assume that the way that we tend to do things today were the way that we have always done things. And when new things come up, we tend to think that these things are new when they might have actually came out of the 70s, right? So what can we learn from the way things used to be done, and an understanding of how software is kind of cyclical and things come up and they go back and all that kind of good stuff. So first, a little bit of a theory. My theory is we get very bored at work, right? So as we like a challenge, we come up with new things. And these new things are not necessarily better, but they're different. Sometimes we like them because they're hard, and that gives our work challenge and it's new and novel, but we can potentially be digging holes. We also tend to really associate with particular groups and movements that we're a part of. So in Cat's Cradle, Vonnegut comes up with this idea of a grand falloon, right? So it says like, who am I? Well, I'm a wolfpacker because I'm a wolfpacker. And what does that really mean? Well, it's a group of people you associate with, but does that really affect your thinking? So if you say, I'm an agile person, that instantly colors a lot of your thought, and you want to kind of stay with this group of people, but really, is that your identity? And we kind of think that there's one true way and the other ways are wrong, and that's really never the case, that there isn't really one correct way to do things. So a few non-technical things and a few technical things. Think about the words that we use to apply things. So we're in the middle of a political season, and I'm not going to get into anyone's preferences, but Affordable Care Act versus Obamacare, the same thing, but just the way that we address the word brings a lot of meaning, and we talk about it one way and it's negative, and we talk about it another way it's positive. Think about going back 10 years ago, the Patriot Act, right? Well, how can you vote against something that's called the Patriot Act? Well, because it's already got this name, right? So Agile is one of those things that came with this name that implies it is more agile, and the thing that it replaced was less agile. And that can shut off our minds. Monolithic is kind of the same thing too. It's like, well, we've got this one big rock, right? We don't really think about what that actually meant and the advantages of those architectures. Microservices, they sound small and fast, but can we actually think about what are the disadvantages? We use other phrases that got pushed upon us from software engineering consultants back when Agile was getting rammed down everyone's throats, right? Big design up front. That's supposed to be a bad thing. But when is it and when is it not? So, like I said, I named Ansible after Zinder's Game because I liked the book. I like the idea of controlling a lot of ships over a great distance. But the word Ansible originally came from Ursula Le Guin. And she wrote a book called Earthsea. And in that, there was a wizard that could command people by knowing the true names for things. And this wasn't saying a squirrel was a squirrel, but the squirrel had a secret inner name. And if you knew the name of the squirrel, he was yours to command, right? So you could be a great squirrel commander. You have to know things as they really are. And as if we think about the labels of things, when we think about Waterfall and Monolithic and Agile, those aren't the true names because we don't really understand the nature of the beast. So waterfall development, right? What does that really mean? It's the idea that we start with really strong requirements and we know what we want. We spend some time designing what that solution would be, and we implement that design. The criticism there is that requirements change, but that's just kind of life, right? So iterative development is the idea of like, I'm going to develop this in phases. There might be 3 iterations before I release. And that's fine, and that's a good thing. So there was one thing that I liked about that movement was there's a lot of time to design solutions and do research, right? So I come from an engineering school, right? I think the idea of software should be rooted in algorithms and design and sort of a rigor to that. And I think what we've done is we have criticized the time that we would have used for design and planning and said planning's a bad thing, right? And that may be controversial and you may disagree with me, and that's fine. We used to have marketing requirements documents, right? So the idea that marketing would come back with like a 30-page, this is what I want and why, we shall do all these things. It wasn't that we had to do exactly what marketing said, but we had this document that said, these are the things I want, and we can read it. And it wasn't just a compendium of hallway conversations that we had to keep track in our head. And we could come back from engineering and say, engineering has this response. We will do these things. We disagree with these other things. And there was a negotiation process and a document and an agreement. A lot of times, software engineering gets criticized relative to other forms of engineering as not being engineering. We talk about software craftsmanship, and we think of it in terms of plumbing and carpentry, and those are honorable trades. But part of the reason it doesn't feel like engineering, and part of the reason that things break and don't work, is because we've allowed it to become less engineering related. We don't have time for design and science. One of the other things I really like out of those processes is we had a really good idea of the strengths and weaknesses of individual team members and their interests, right? So people could specialize. There's a trend in Agile to assume all developers are interchangeable, and I personally believe this is incorrect. I think there's room for a lot of people to learn, but certain people like to do certain things. And it's not true that everyone can estimate everyone else's tasks and you can just grab the next task on the pile at all times. And we understood dependencies. This is a Gantt chart. People used to make fun of these in Agile land, and I think that's kind of sad. Because what it means is somebody spent time to understand that I have to do this thing before I need to do these other things. And that's just good planning, right? So now we have a list of tasks, maybe, but what we really have is a list of features. But if we take time to actually see how much everything takes, we can kind of spend time on design and understand, well, what are the things I know and I don't know? And if you can come up with a plan, that may not be your final plan, but that's a good thing. So sort of a confession here. I've quit 3 jobs because of Scrum. I don't know what happened, right? So my interest is in systems engineering and software design, right? I came out of a very object-oriented background and like to plan things and do things the right way and whatever. And I kind of got into an environment where I spent 50% of my time in meetings, right? I actually like meetings. I'm kind of like extroverted in some ways, and like I enjoy talking to people, but these were kind of stupid meetings where like every single day we'd recount the same status, and then on Friday we'd spend another like couple hours redoing the same status. And then we'd have a planning meeting where we'd basically plan what we were going to say for our status, and then we'd have a retrospective to talk about what we said for our status. And well, I don't know what happened here, but I kind of feel that this whole movement got pushed on people with such like a level of religious indoctrination. We said if we didn't like it, we must have been doing it wrong. And that kind of killed discussion, right? It goes back to some of those earlier thoughts about labels, right? So, how do you vote against the Patriot Act if you're not, how are you not a patriot? So you don't like Agile, so you're not Agile, right? And that's all about labels. So scope has become a lot more unpredictable. So we say that we don't estimate in time, but everyone knows when a software has to go out at a particular point in time to time the market, right? If you're a startup that's releasing code, your users are going to expect it to come out at a certain frequency and have certain features. Scope and time both must be set, as well as quality. There is no good, cheap, and fast pick two, right? You have to understand the balance between all three of those and then where you are in that balance. And you're never going to achieve any two of those. You're just going to be somewhere in the middle of that triangle. And we spent all this time in status that we've lost our efficiency. We've also basically allowed crunch time to become constant, which is really bad for us as people, right? We get really basically tired and burned out because everything is always a deadline. And that's kind of counterproductive as well. So even we take a step back from Scrum and we go to lighter weight Agile methods, we see that we still shorten design time. Like you get an estimate and somebody says, well, you gave me 2 weeks. How about 4 days, right? How many times has that happened? Requirements are a sentence long instead of 2 pages, right? Because we don't take that time. And we just assume we know what people mean. And then we get back to the end of the iteration and people say, hey, this isn't what I wanted. Let's redo this. We're Agile. And testing can suffer because things are kind of always evolving. So there is a middle ground. I need to get a little bit going to my second half of my presentation, so I'm going to speed up a little bit. We can share design. Having accessible product owners are a good thing, but requirements are a good thing. And iterative development processes that embrace some of those lessons from Waterfall, having strong requirements, maybe having 4 iterations versus continuous iterations every 2 weeks, can roll back that tide. So I think that's a worthy discussion to have. Another thing that we say is really bad, and I think this is a more technical part of this talk. We say that monolithic architectures are bad. And there's this big push to containers and microservices, and perhaps controversially, I think this is a bad idea. This is a classic web application architecture for a, quote, monolithic application. This is really a 3-tier app. We have an application tier modeled by a bunch of load balancers, a message bus, various backend engines. There's basically 2 types of software in this stack. There could be some content servers, whatever, very simple. We've seen this many, many times. This is not showing up very well on the screen, but over on the right-hand side, you can see each one of those little dots is a microservice in a particular architecture. I got this one off the internet. I think it comes from Halo. I'm not sure. The taxi hailing company, not the video game. So these are all the communications between all these different services, right? Was this designed, or did it just happen? I think it just happened, right? So maybe that is the optimal design, but we'll never really know because it wasn't designed. The thing on the left is an old design diagram for OpenStack. I'm not sure if it's actually a good design diagram or not, but again, it's a big ball of goo. And again, I don't think it was designed. I think it just happened. And this other little diagram, I think, is just conceptual. But the idea is we have all these instances that are just randomly talking to each other, and somehow in the end, that's supposed to be the optimal software system. I don't think there's a proof that actually says that is the optimal software system. One of my favorite quotes: "We replaced our monolith with microservices so that every outage could be more like a murder mystery." So that happens, right? So what we've done, instead of being able to debug something and get a coherent stack trace, we understand that this system failed, but why it failed is it probably got bad input from another system, which probably means it got bad input from another system, or something else happened. And you're really dependent on deciphering logs from a log aggregator. And log aggregation companies are doing a great job at trying to make this manageable. But compared to older models of debugging where, oh, I've got a stack trace, I can see exactly what happened, we have a lot less information. Debugging an outage in production is only the tip of the iceberg. So I worked at a very cool company recently, and they had a microservices architecture. And honestly, I think it worked for them for some different reasons. One of those reasons is it allowed people to not get involved in code sharing and code review on a very massive scale. So microservices are a solution to a people problem where groups don't want to necessarily talk and say, I accept this API, you accept this API, let's go do our own thing. And that's fine. But what happens is, in these kind of configurations, is you can have thousands of EC2 instances when you could have probably had 50, right? And a lot of that's because of the, not only because every service is its own instance and some of them are running at very low utilization, and yes, you can horizontally scale them all differently, but because of the slowness of network communication between them where you could have just had a function call. And the fact that everybody can do things differently, why we kind of started that model to get away from code sharing and code review, which were controversial, we've now had this higher problem of trying to make sure all these different service teams are doing the same things, once again, the same way and not differently. This time possibly in multiple languages. And then the DevOps team has more things to deploy. So microservices are really appropriate for a more sophisticated IT shop, but we've kind of been pushing them as the way to shops that don't really need to go there yet, right? They don't have these communication problems that they're trying to solve. And the other thing is that inefficiency kills polar bears. So we all should be concerned about energy utilization, right? A little bit. You're not all running from clean power, and if you are running from clean power, if you weren't drawing so much power, that power could be sold elsewhere. So if you think about like any social networking application, say Facebook, burning all these servers all these times, releasing all this heat and energy, somewhere polar bears are suffering a little bit. So we should care about those things. We really should. So we have a responsibility to write efficient software. So with a monolithic architecture, it's also easier for me to run more of the actual live code on my laptop, assuming it's not a very bloated application. I don't have to run 20 different services or 100 different services. I have everything. I can do static typing checks between communications, right, to know that code is actually going to work. I can do more easy testing. And I have less different types of servers to deploy in production. So I can have a simpler operations architecture. I don't have as much utilization problems because all my instances can just be scaled out when they have load. I'm basically running all my code on all of my instances. And if particular functions aren't being called as much as other ones, it's not a problem. We don't have this problem of needing containers. I'll get to that in a little bit. I'm not a big fan of the push to container software, which may be also a little bit controversial, but I'll explain why. And version upgrades are another issue. So if you have an API and you want to change your API in code between releases, that's pretty easy. But if I want to change my API in a service, I kind of have to support both versions of the API until all the other microservices move off of that API, right? So we've created this big versioning problem that we didn't have before. So in trying to not have these communication problems between teams where we can't do code review efficiently or agree on things, we've created other communication problems, and we've actually created way more technical problems. And this kind of happens because we didn't realize that we were trading one thing for something completely different, right? So I've already talked about this to a great extent, but we're trying to solve a people problem with software, and we created different people problems. Maybe they're better or easier and more software problems. In the old days, we used to run software directly on bare metal. Then we started to run virtual machines and cloud software. But we see things now where people are running VMs and they're installing things like Kubernetes on top of their VMs. And then they're running containers inside of that and their apps inside of containers. I see this on EC2 where people are running additional clouds on top of Amazon. Why are we trying to make things hard, right? In many cases, the cloud already provided you a way to auto-scale VMs, right? The whole container utilization thing happened because of microservices to a degree, but it creates this extra failure layer of now I've got to manage this operation stack. And we also see this in other areas where we're trying to manage message buses that are hard to scale or data stores that are hard to scale. And these new things that we try to embrace because they're new, and like I said earlier, we get bored, or can be actually quite a pain, right? They're new and flaky and whatever else, and they're changing very fast and they're very hard to keep up with. And I think when we do that, we get obsessed with keeping up with the technology, and a little bit less keeping up with like software design and what does our object layer look like? What are our algorithms we're using? And things that, to me, are more interesting in the kind of the core of computer science. So there are some good lessons from microservices. If we go back to the earlier principle of an honest evaluation of something without applying its labels, speaking for it as it is. Encouraging language and tech choice, and people not saying everything in this organization must be, say, Java, is a good thing, right? Within reason. You have to be able to hire people that are able to work at all the different language levels that you want. You don't want everybody to pick different things where this team picks Scala and this people takes Clojure and this people takes Rust and these people have taken Go. That can be really hard for hiring and all that, but it does encourage documenting interfaces, and interfaces are important things, right? So knowing that the API is stable, right? And because people will yell at you if it was not, right? Those are good degrees of separation. Some of those practices can avoid things like law of Demeter violations, which are good, right? I'm loosely coupled. And an API focus and better UI decoupling are good things. But in the end, everything has trade-offs. So just getting into a little bit of what we've come to here is we kind of tend to say that monolithic is bad and microservices are good and agile is good and waterfall is bad, but in reality there's lessons to be learned from both things, right? So we have to make sure that we don't get caught up on those particular trains of thought, right? If you're deploying your own software architecture and you're building a SaaS application, your users are really only going to care what your public API is and what your user interface looks like. You're free to make whatever backend choices you want, right? If you're not releasing software every 2 weeks and you're really wanting to release to your customers every 2 months, you're free to make whatever software choices you want. I think like some of the other older approaches are more computer science-y. Like we can focus more on algorithms and we can focus more on design and spend time in design and research and prototypes. Whereas Agile tends to want to crack the whip, right? Microservices wants to similarly crack the whip and say, I'm not really going to think about this. I'm just going to release another service, right? I think we can step back. But there's something to learn from everything. Like there's advantages and disadvantages to all types of approaches. But as we stop thinking about the labels, when we stop saying, I have to be agile because if I'm not agile, then I'm not agile, doesn't really mean anything anymore. And that's kind of what I want to get us towards. So as we have talks throughout the day, I guess the takeaway I really want people to think about is try to teach people new things, try new things, and don't just try to attach yourself to the industry hype curve, because everybody's jumping on a particular bandwagon, and like lately that's containers. If you don't feel it's right, you can still do what you want. And I think that's how we advance computer science, is by trying lots of different approaches and not assuming that there's like one true path. So that's the end of my talk. Thank you very much.